This recording covers Gay Lussacs gas law. What we're going to be looking at here is a pressure-temperature interaction, and we're going to be looking at the pressure of a gas being directly proportional to its temperature in Kelvin. The equation for this is that P1 over T1 equals P2 over T2. So P1 over T1 equals P2 over T2. This is a direct relationship. If we were to graph temperature as the independent variable and pressure as the dependent variable, as the temperature increases, we see the pressure increase in a linear fashion. So as pressure increases, temperature also increases. An example of this in real life would be an aerosol can, one of those things that you use to hold shaving foam or spray paint or something like that. You do not want to throw these in a fire because this is a rigid container. If you throw it into a fire, what happens is the gas molecules start moving around more and more rapidly until the pressure inside the can exceeds the strength of the can. The can explodes in a big boom. Now let's take a look at a couple of calculations for this. The first one is we're going to look at why you need to repressurize your car tires as the weather shifts from summertime to wintertime. So we're going to start with the tire pressure in the car's tires at 2.3 atmospheres at 38 degrees C. And we're going to see what happens to the tire pressure at minus 10 degrees C. So the first thing we're going to do is we're going to change these temperatures here to Kelvin because we have to use Kelvin. So let's put in parentheses here. This needs to be in kelvins. So if we have 38 degrees Kelvin, that's going to be 311 degrees K. And we're going to minus 10 degrees C, and that is 263 degrees K. There's our P1 right there, and we're trying to figure out what P2 is. So 2.3 atmospheres is to 311 K, as our new pressure, P2, is to 263 K. We're going to cross multiply and divide, so 2.3 times 63 divided by 311 equals, and we're going to go to one significant figure, 1.9 atmospheres. Always include your units. Let's put a box around it to indicate you've finished the equation. Let's try another one. We've got a cylinder of gas, and at 0 degrees C, the pressure is 770 millimeters of mercury. What is the pressure of the gas when the temperature increases to 500 degrees C? Once again, convert to kelvins before doing any gas calculations. This is 273 Kelvin, whereas 500 degrees Celsius is equal to 773 Kelvin. There's our P1 right there, and we're trying to figure out P2. So we're going to have 760 is to 273 as P2 is to 773 Kelvin. When we work through the math, you're going to get 2,200, this is with significant figures, millimeters of mercury. Put a box around it so that everybody knows you're done, and you're ready to try some Gay Lussacs problems.